Hello everyone, welcome to our this video where we are going to talk about two most important topics for computer science and briefly covered in your CBSE syllabus, that is searching and sorting. In this video we will introduce and put a formal definition for what exactly is sorting, and then we will introduce three variants of sorting that is prescribed for your syllabus. Post that, we will take some numeric example, introduce these algorithms one by one, and then cover set of metrics or sub-steps from these respective algorithms that is tested in your CBSE board exams. So those will be number of swaps and number of passes given a numeric data set in an array. Then we'll conclude this with a brief overview of worst case, best case, and average case time complexity for each of these sorting algorithms. Then we'll take another detailed numeric exercise where we'll visualize each of these algorithms and look at how many comparison, how many swaps are happening as we iterate through the elements over the array and eventually reach out to the last stage where the array is completely sorted. So with this, let us get started with sorting. So broadly, we have organized our slides. We'll actually talk about three sorting algorithms, that is bubble sort, selection sort, and insertion sort. We'll look at its time complexity, and then we'll take some exercises and examples where we'll actually look at the count of swap and comparison done for respective algorithms. So sorting the process of arranging the elements of a list in a specific order that could be both ascending, which means that increase as you move from left to right, or descending, which means it decreases as you move from left to right. Efficient sorting helps in optimizing, searching, and managing data better. So there could be scenario where data is not sorted on the primary key if you are talking about a database, and if you need to organize it based on some metric, for example, students sorted by average marks. So every time then you have to look at the whole list to answer it. But if you sort it once, then you can answer the one with highest score, the one with the second highest, just by doing a simple lookup. So that's why sorting is important, because many of real life use cases require us to arrange it in order and then help us answer the largest, the minimum, or even the rank. There are two other sorts which will not be, which is not prescribed at your syllabus and will not be covering it in much detail. They are merge sort and peak sort. Outside exam coverage, you should be aware of them because each of these bubble sort, insertion sort, and selection sort, they have their own inherent problem in terms of the time complexity, and they are not suitable for big data ecosystem. In big data ecosystem, one of the algo that always work is a variant of merge sort that we call external merge sort, where you compare sublist and actually in memory and then write them back on disk, and then you continue the process till all of your data are sorted. Quick sort, on the other hand, is a very clever and is the most used sorting mechanism, where it intelligently try and find out the there is a concept called pivot. So it will start with some random guess around where your from where you can divide your list in two ways. Once we see some introduction of insertion sort, we will see that quick sort is an intelligent version of insertion sort, where you make some guess about initial guess about which element divides this inequality two part, and then you sort those two parts recursively, and keep going down until there are only two elements. Until that subset is sorted, right? You keep going down until two is actually the merge sort, where you keep dividing the array in two part unless there are only two elements left, where actually it will be already, you will actually swap and sort as need be, and then you keep merging upwards, right? Quick sort actually try and find an element that can roughly divide all the elements lower than this on one list, all the elements higher than this on another right side, and then actually it sorts actually the subset separately, and then actually eventually the whole list is sorted in place. So that will be only for your knowledge perspective, and once you get some time, you should practice from a practical perspective. Okay, so let us introduce the bubble sort, right? The idea behind bubble sort, as the name suggests, right, is when you are having an array, it's likely your elements will not be sorted in one go, right? The idea behind bubble sort is in every pass, right, the biggest element, say if you are so let us by default let us assume that all these sorting algos are about increasing or ascending one, right? So in that case, in every pass, in your first pass, right, your largest element will reach towards the end, right? And how it does, it will start comparing the two elements, and if they are out of order, it will swap them, right? So it means that out of order means what? If your left element is more than the right one, it will swap. So eventually, once you compare all the element in pass one, the biggest element will be in the right? Then the second one, it will actually do from begin till one position prior. So if length of it was n, and say you are doing the whole list first time, and next position is now actually having the right candidate. So the next iteration will be from begin till n minus first one, and so on, until actually you actually fill even the last element in your last iteration, right? With that in mind, so basically what it is doing is it compares adjacent elements and swaps them. Swaps means reverse them, right? The swap, right? If there are two variable x and y, and if you swap, then y becomes x becomes y, right? And here why you sort it? Because if the element is a 3 and 7 and 3, if you have to sort it increasing, things would come first, 7 should go next, right? So that's what the swap means here. That whenever the elements are out of order, as per your target sorting criteria, you swap them, and your bubble sort helps actually at each of these steps getting the biggest element, right? So in that way, bubble sort is simplest sorting algorithm. You can see on right hand side when we have defined bubble sort, right? So n is simply taking the length of array. That is the second line that we are talking about. If you can see the place where my mouse is hovering, and then what you do, you set up for I in range of n. You know what range of n does? It will go from 0 till n minus 1, right? And for each of these I, you do j from beginning till ith element, right? So if you look at this, this statement, right? When you are actually processing the first element, it will become I is 0, and so it will become n minus 0 minus 1, which is n minus 1. So for the first element, it will go from j will go from 0 till n minus 1. It means the whole list will be seen, right? And if there are any out of order, those elements will be swapped at each place. So by the end of the day, your biggest element will be at the end. Then what will happen in the next iteration? Your I will become 1, and when your I is 1, then your j will become n minus 1 minus 1, right? That is n minus 2. Why n minus 2? Because n minus 1th element is fixed, right? Then look at the third time, right? Your I is 2, and then your j become n minus 2 minus 1, that is n minus 3, which is from right the third element. Why? Because n minus 1 and n minus 2 elements are fixed. So and so forth till actually you'll reach the stage where your I is n minus 1. Where your I is n minus 1, then n minus n is 0, and minus minus is 1, and 1 minus 1 is 0. So basically in that case your j becomes 0th element, and it will actually just look at your I is I at this point in time will be n minus first, and j will be your 0th element. So that final comparison will happen, and if it is out of order, it will be swapped, right? So just look at the two for loop. Only thing that you have to keep in mind is the j is going from from beginning, that is 0th index, till one index prior to the ith one, right? Always keep in mind, right? Why we are doing n minus 1? Because we are going to access this item with n minus 1, because it starts at 0, right? So nth item will be out of reach. That's why n minus 1. So n minus 1 is because of setup, right? And then why you do minus I? Because you whenever we are processing ith element, right? You don't want you assume that ith element from the right is already set correctly, right? That's how you actually get into this loop, right? So just to summarize, just look at this. If this algo is clear, you can stop this video. If you want, you can rewind and listen again. If not, you just read through it, right? Very simple. Compares adjacent elements and swaps them if they are in the wrong order. Then the only thing you have to understand is the loop start from 0 till n minus 1, right? Ith one, and j go from 0 till 1 less n minus I. So for the first iteration, right, what will happen? It will start at 7, right? And then you are having 7, and your comparison, so your I will be 0, and then your j will be, it will go from 0 till n minus 1, and then it will first compare if your array of j, right? So it will actually compare, because it will be comparing in the very first loop, right? So what is n here? 2, 4, 5, right? So 5, and I is 0, so 4, right? We go from 0 to 4. So 0, 1, 2, 3, right? And then you can look at, right? If array of j is greater than array of j plus 1. So what is j here? 0. So what it is saying? If 0th element is greater than first element, right? 7 is greater than 11? No. So it will leave it as it is, right? And then this loop will continue. So the next time there will be 1, and then it will look at if 1 is greater than 2, array item at 1 is greater than 2, which is 11 and 3. So if 11 is greater than 3, yes, 11 and 3 will be compare and swap. So this is the place where your one swap will happen between 11 and 3. Now how your array will look like? 7, 3, and then 11 and 10, right? Again, what will happen? 11 and 10, 11 is more than 10, so 11 will be swapped. So you have 7, 3, 10 and 11, and then finally 11 is less than 17, so it continues as it is. Now at the end of the first loop, the 70th word is at its own position, and then you actually keep sorting from 7 till, so that is 0th element till 4th element, 7, 3, 10, 11. Again, what will happen? 7, 3, 7 is greater than 3. So next loop it will be swapped 3, 7, 10. 7 is less than 10, that is fine, you leave it as it is. Then 10 is 11, less than 11, leave it as it is, right? Because they are in order. So now this is again in order. You have done so far 7 to 11, 7 to 11 to 3, one sweep. Then 11 to 10, 2 swap. Then in second case 3 to 7, third swap. And here you are doing nothing, right? Only your list is already sorted. So you can actually practice it through a smaller arrays. Make yourself comfortable. Look at the loops. Loops are very simple. Just two loops. One top level loop on the ith one, and then the second loop that is on j, that goes from again beginning till one item less than the item that you are processing in I. Great. So as you know, there are two loops out here. Every time you are doing n-1 comparison, so it goes like, you know, n into n-1. And as you know, if there is single loop, complexity, you call it on. When there are two loops and all the loops are executed unconditionally, your complexity goes to on square. Unfortunately, for bubble sort, you don't have a premature, closure of it. It will keep comparing all the, elements as it iterates through the loop. So it's all best case, average case, and worst case complexity. All is on square. So bubble sort is a very simple sort, excellent for a small data set, easy to understand, fundamental, you can quickly implement, faster to run only when you have a smaller data set, right? It will be problematic when you have big data, say actually, millions of data set, right? And something like that. So with that, hopefully you have got some idea, working idea about bubble sort. This is what that you need to know. Remember, from your exam perspective, most likely the question that you are going to get asked is number of swaps done. And for that, the only thing is you follow the loop. For bubble sort, keep in mind, you actually take the first two elements and just keep comparing. Whenever they are out of order, you swap them, right? And accordingly, you modify the least element at the end of iteration, then again start, till you are actually processing the last two elements, right? Okay. Now selection sort, in some way, what bubble sort was doing, it was bubbling, right? So the biggest bubble towards the end at the at the start of each iteration. Selection sort is actually reverse of bubble sort, right? So it finds the smallest element and sort of put it in beginning. So it's little sort of counterintuitive, and it's rightly so, because what it is trying to do is, rather than keep iterating, right, all the way till end, it is trying and find out, right, if it has seen the smallest element. For the first one, it will look at the smallest in the array. For the second one, second smallest, and so on, so forth, right? So accordingly, the way actually your bubble sort was building from the end, it will begin from beginning with minimum element, right? And what is the way of looking at the minimal element? So say actually you set up your minimum element as the first array, right? First array element. Then you simply keep comparing from the rest of the array items, right? If they are less than this, right, then you keep swapping, right? And eventually the least available item at the end of the day will be that index will be known, and then you can swap that with the beginning item, right? That's the whole idea, right? You got it? What we are doing here is simply you have your smallest item assumed to be your first item in the array, right? Then you start comparing from the second item. Say for example 7 and 11, right? So 7 is still the minimum, so you assume that 7 is the least. It might not be the case, right? Now compared with 11, you don't need to change. Now you have compared with 3. What is the least element now? 3. So you swap that 3 to 7, right? And 7 is now here. Now you compare 3 to 10, fine. 3 to 17, fine. So how your array elements are? 3 will be in beginning, and then 11, 7, 10, 17. Keep this in mind, it's very, very important. Now the second element, what you will do, you assume that your first is in order. So you do your iteration from second element, that is 11. So 11 and 7, right? If you see it is out of order, so it will get swapped. So your that is the second swap, it becomes 7 11 10 17, right? Now you have to compare 7 from 10, right? Since 7 is uh, less than 10, it is fine, right? Then again 7 is less than 17, it is fine. So what will happen at the end of the iteration? 3 7, right? Now you compare 11 10 17, because this is the unsorted one. 11 10 out of order, so it will become 10 11, and then you compare 10 with 17, right? And then 3 7 10 is in order, and 11 17 is in order as well, no swap needed. So you can see that by the end of the day array is sorted, right? So just the reverse of bubble sort is selection sort, right? Name is selection sort because every time it is making selection for certain position. In ith loop, it is making selection for ith element. So what you will do here, actually your minimum index is going to start from ith. So first you take the length of array in n, then you set up your for loop from I till range of n, and your mean idx element here is going to be I. So your j is going to be from I plus 1 till n, right? And then if your array of j is less than array of mean idx, what do you do? Mean idx is j, right? At the end of the day, what you do? You actually swap, right? Ith element and mean idx with mean idx and ith element, right? This swap, you can actually check, right? Put it in the flag, right? So I think we can modify this and push this array I and array mean idx, right? Only when you need this, or you can get it done there itself. I think we have to get it done internally. So here again, if you look at in terms of complexity, again there are two loops involved, and all the comparison are done. So on the best case, average case, worst case, you don't have any idea, but you have to compare with all the elements, right? You might have seen. So all will result into ON square. Selection sort very similar to bubble sort. We are done with these two. Let's move to insertion sort, which is actually very, very interesting. Insertion sort is having a different philosophy, right? It starts with that frame of mind where iteratively it takes one element and find out its correct position. How you can do that? So for example, if you choose, say a random element, right, from the array, you can compare from begin, right, and you can compare from end, right, and find it out that how many elements are less than this, how many elements are more than that, right? So you know that it is going to fit just around all the element less than it, and before your all the element greater than that will start, right? And just to organize this as a program, again in selection sort, you might have seen the idea, right? One part of array is assumed to be ordered, another part of array is assumed to be unordered. So in beginning, every stage, initially there was nothing sorted. In the first iteration, first element was in place, second element, second, third, right? So you assume that now from the left, your array is in sorted order. Here also we have that idea where we'll assume that part of the array is already subsorted, and whenever we see an out of order element, right, the comparison will start for every element in this subset. This will become very clear. Let's take this example, right? So say 7 11 3 10 17, right? And let's start with 7 as assuming as it is your sorted one, and assume that 11 3 and 10 17 that they are not sorted. Now what it is doing, it is just testing with the first element of right hand part, which is from 11 3 10 17, right? So you can just I'm not sure if you can see my mouse. So from 11 onwards, right, you assume it is actually unordered and assume that 7 is in order, right? Now what will happen here, that if 11 is greater than 7, it will just stop here and assume that these starts in order, right? In the second pass, right? Now it assumes that 7 and 11, right, is in order, and 3, 10, 17 is in order, right? So then what it does is it compares 3 with 11 and it is out of order. So it simply doesn't swap only, 3 and 11, right? It will actually be keep going till it finds the minimum element on the left. So what will happen? Your 7, 11 will be as it is, and 3 will be compared against 11. It is less, so it's fine. Now it will actually compare against with first element, that is 7 with 11, right? And so 3 will actually bubble down to first position, and 7, 11 will be its order. At this stage, we assume that 3, 7, 11 is sorted, and then again 10, 17 is unsorted part. Now you start comparison between 10 and 11, right? They are out of order, so it will actually compare again 10 with 7, right? And since it is more than 7, the this will stop here. So it becomes 3, 7, 10, and then 11, 17. Now 10 and 11 are in place, so nothing will be needed, and this can stop here, right? So as you might have seen, the difference here is the moment it finds, right, that elements are in order, it trusts that they are in order, right? And whenever it finds elements out of order, then it actually keep comparing till beginning of it, right? So in the best case, when your array is completely sorted, just in one linear search, right, it can determine, right, that the list is sorted, right? Because and then it can exit. So best case, only out of these three that we discussed, bubble sort, insertion sort, selection sort, only in case of insertion sort, the best case is ON, right? Worst case, average case will be ON square. And now let us look at the implementation, right? What you are going to do, you are going to be from I in range 1 till length of the array, and then you look at take a the ith element in your array. Your j is actually just one prior to this, so your j is pointing to the unordered part first thing, right? And then from there on, right, as long as j is greater than 0, and these keys are in that sequence where your key is still less than 8, right, it will keep swapping and going down, and eventually it will actually swap the items and then return the array, right? So this is interesting, and can be actually one of the, you can say actually kind of the relatively better guy out of these three. To play attention to insertion sort, take some example. That's the only way of getting clarity. Time complexity, just for review, bubble sort, best case ON square, average case ON square, worst case ON square. For those of you who are seeing the time complexity related notation, ON notation or big ON notation, big O notation, the way we call it, first time, you can assume for each execution of each loop, for or while or whatever, right, that constitutes a noun ON. Why ON? Because every loop will actually look at all the elements, even if it doesn't look, right, then also it is considered ON. ON by 2 is as good as ON. And then if there are two loops, by default it becomes ON square. If some condition makes the looping redundant, in that case it becomes ON. That's what you saw in case of insertion sort. If items are in order, first iteration, it will not go for the second. That's why the best case complexity for insertion sort is ON. Okay, now this is the the kind of question you can expect in your exam. So you are given an initial list 7, 11, 3, 10, 17. Not sure if you have taken the same in our earlier example. And then for each of bubble sort, selection sort, and insertion sort, you will be supposed to find out that how many comparisons were done, how many swaps were done. A variation of this will be asked, right? Comparison will be anything wherever you are comparing the two number based on your looping constructs, right? Swap will be counted only when they are in out of order and you are swapping them, right? And typically, more often than not, swap will be tested more frequently. So if you take this example, 7, 11, 3, 10, 17, let me do it for bubble sort, and you can actually kind of stop this video here and do it yourself for selection sort with a pen and paper. And the same with insertion sort. So in bubble sort, what is going to happen? Uh, we actually pick an initial element and we'll keep comparing it against all the other elements. And whenever they are out of order, we will move them towards the end. So 7, 11, right? What will happen? 7, 11 are in order. That is fine. And so what we'll do here, we'll actually compare 11 and 3, right? So it becomes 7, 3, right? 11, and then we compare 11 and 10, so it becomes 10 and 11, and then 11 and 17, right? So they will be in order. So eventually in the first case, right, so what you are doing, if this number is greater than the other one, right, then you keep the, basically it's kind of keeping track of the biggest elements seen so far. Out of 7 and 11 it is 11, out of 11 and 3, right, out of 11 and 3 it's still 11, out of 11 and 10 it is still 11, out of 11 and 17 is 17 that is largest. So 17 stays there, right? And count swap that you do is 11 and 3 1, and then 11 and 10 2. Okay, then the next list, what will happen, right? At the next list you are having your these are 7 3 10 11 17. Now what will happen? 7 and 3 they are out of order, one swap, so it becomes 3 7, and then 7 and 10 is fine, and 10 and 11 is fine, and that goes on, right? So this is our third swap now. Now we have got 3 7 10 11 so that's not the fourth one, right? So eventually now the list is in order and we have done 4 swaps. So in a similar way, you can why comparison is 10. So for each time, right, first loop we are doing 4 comparison, second loop we are doing 3, third loop we are 2, and the final loop 1, right? So you can actually look at what is happening there, right? N into, so our count is 5, right? 5 into 4. So the formula for finding comparison for selection and bubble is easy, n to n minus 1 by 2. Swap is the only thing that you have to determine. Okay, thank you. So with this, what we did is in this video, we introduced sorting. We looked at the 3 kind of sorting which is tested in the exam, that is bubble sort, insertion sort, and selection sort. Then we introduced those individually, looked at the algorithm, the code, and then we actually walked through an example and talked about its complexity. The same thing with insertion and selection sort. What we should keep in mind is bubble at the end of each iteration it gives the highest element on the right hand side. Selection on the other hand keeps the lowest element on the left hand side, while insertion sort at the end of every iteration it finds one element at its right place. In the second it will find 2 elements at its right place. Third element is the right place, so on and so forth. So with this, we'll pause here, and we will sort of cover our searching. So there are 2 very, very interesting searching variations. They are actually having incredible practical values, as well as very, very important for either your computer science journey or data science journey. They are binary search and hashing. Of course, we'll actually talk about linear search to start with, and then we'll look at the kind of questions that you'll be typically tested in your exam. Thank you. Thanks for being here till the end. Do like and subscribe my channel, and see you.